Double integrals in area. We have a region here. X goes from 1 to 4, y goes from 1 to 3. This can also be indicated by the Cartesian product 1 comma 4 times 1 comma 3. It's what's called a Cartesian product. And we can find the area using a double integral where x goes from 1 to 4, y goes from 1 to 3, dy dx. Conceptually speaking, we break this up into a grid. Dimensions are dx is a horizontal change, dy is a vertical change, dy times dx gives us what's called dA, a small little piece of area. And the way this gets added up, think of the outer limit as being x. X goes from 1 to 4, that goes with the dx. This is how these limits pair up. X goes from 1 to 4. For each x, y goes from 1 to 3. So you start out at x equals 1, and we'd add up all these squares. And then we could conceptually change x by a little bit and add up these squares, these squares, these squares, these squares. It adds up all the squares, which gives us area. Now, in terms of evaluating, we're going to start on the inside. And we get integral from 1 to 4. Integral of dy is y from 1 to 3 dx. Plug in 3, plug in 1. We end up with integral from 1 to 4, 3 minus 1 dx. I'll leave the 3 minus 1 there till the end. And of course, the integral of 3 minus 1 dx, 3 minus 1x, from 1 to 4, which is 3 minus 1, 4 minus 1. Guess what? That's 2 times 3, which is 6. And that's the area of this region. So very easy if you have a Cartesian product 1 to 4, 1 to 3. Basically, this is x, this is y. It goes right to the x limits and the y limits, and then we integrate. So that's all for double integrals in area. We'll be back with a video on math shortly.